Namaste everyone,
It's me, Sarad,
it's me Suman Dangal.
and together
We are Dristi AI.
we are the students of Southeastern State College. We have been researching this for about 2 years at the High School Research Opportunities Program at the Southeastern Academic Research Center, and we are very excited to share it with you.
Dristi AI image analysis for detection of hazardous microbes in human bodily fluids. Today we have segmented this outline and we'll be talking about this later as well. To introduce all to our system, let us first go to its background. And in third world countries like Nepal, the ratio for doctors and health center is very disproportionate. For every 100,000 people in Nepal, there is only one doctor assigned. And according to latest data from Nepal's Health Council, it is known that there are around 8,700 health centers in Nepal. Among them also, 75% of them are situated in rural areas of Nepal, to be exact 6,586. And every year, around 5,000 doctors graduate and they are obliged to serve in rural areas of Nepal. Even after we subtract those numbers, we are still left with 1,586 places or 1,586 health centers, which always faces the scarcity of those required health professionals. Now, what we want to do is that we want to reduce those numbers and get the help to those needy people. Dristi AI, we have built this AI so that we can help those people by just examining their bodily fluids like blood and urine. Our ML system, which is a technique called CNN, just detects the abnormalities in those bodily fluids. In this image here, you can see the example of sickle cell anemia. It can be easily visualized in this framework. And what our AI does is basically understands its frame and find out the abnormalities. The basic thing we want to achieve from this system is we want to help people, those needy people which are suffering from those untimely demise just because they are not getting that timely attention, medical attention of those health professionals. To go into the methodologies or those terminologies of our AI, I would like to hand over this speaking term to my friend Sarad.
Okay, and thank you so much. Let's get into the nitty-gritty of our system. So basically, I would like to segment this section into two parts. The first one is the meta part, as I would like to say. It's the actual building of the model. And the second part is how we use the model to detect and diagnose diseases. So first of all, how do we actually build our AI system? What we do is we collect private and public data sets. So these are data sets contains images which shows different diseases. So in the previous image, we see an image of blood smear which contains sickle cells. So the horizontal ones, they are the sickle cells. So what we call those, what those are features. So our CNN models can detect those features, and based on those features, it can label a given image as whether containing a disease or not. So it predicts based on those features if a person is suffering from a certain disease or not. Then what we do is we take all those images, the data set, then we build a model out of it. We use convolutional neural network techniques to build a neural network. Then we compile the model, we save it into a constant graph. And what we do is we export the model to make it fit for inference on resource scarce devices. So here you can see us training the model for 10 epochs, and it gains a good enough accuracy of about 98%, as we can see on the last epoch. And let's get into the actual inference or the actual uses of our model. So what we do is we gain an image from a certain user or a certain patient. So what he or she does is provide us with a microscopic image of the bodily fluid, and we take that image and we feed it into the neural network. And what the neural network does is it pre-processes the image, it resizes it into a certain fixed size, and then it runs the model, and it predicts whether the given image belongs to a certain class or not, a certain label or not, and then it basically predicts if a user suffers from a certain disease or not. And then it provides the result or the prediction as an IQs. So here is the ideal microscope that we worked with, and here's the result. So provided an image with sickle cell anemia, it reasonably predicts that the image does contain sickle cells with an accuracy of about 91%, or the confidence is 91%. And yeah.
So to conclude, what have we done till this date is we have implemented this system or deployed the system in our college, Southeastern State College, and as well as in the municipality in rural area of Nepal, in district called Nuwakot. We have implemented this system, and what it basically does is it collects everyday sample and it always keeps upgrading our database. So it helps to keep us updated and make us more accurate. It is, yes. And what we get from that is we are able to help in a large scale as well. And we are not trying to compete with those doctors or trying to take their jobs, what we say AI will do. But what we want to actually do is help them to serve more people. What are doctors made for? Or not made for, but what actually doctors want to accomplish is they want to serve the nation or they want to serve the patients. And in those places where the paucity of doctors is in large scale, these kind of compatible hardware and software mixture can always get a very shiny result, I guess. And to actually tackle this problem, we have joined our hands with a very group of expert doctors in Nepal, namely the organization named Doctors from Nepal. We have signed a memorandum of understanding with them. They are a group of experts in their field, and they are the, I think, top of the country right now. And what they have promised is they will supervise each and every data the system has collected, and they will try to know if it is effective or is it really that good or not. And we were quite happy to know that the AI predictive model was quite accurate. And how we want to try to go globally with this is we want to provide not only in Nepal, because the last time I checked the WHO, there were 619,000 people dying just because of a disease called malaria. It might be a very common disease to get caught, because every year, even I might get infected once a year, because it is very easily spread. But it's not uncurable. Rather, it can be easily diagnosed if the medical attention is given in time. So to address these kind of problems, we have also joined hand with Innovative Gaihre Nepal. It is a very renowned R&D group in Nepal which have been serving in the field of robotics and innovation. And to help our innovation, they have told us, or they have promised us to help us with those numbers of manufacturer, or how to make that compatible hardware which can be easily accessed or easily portable to any places or shipped anywhere in the world. With these kind of MOUs, what we want to achieve is a national goal or the worldly goal of helping everyone in need. Now, at last, I would like to acknowledge everyone who have helped us in this journey. Southeastern Academic Research Center, Southeastern State College, Green City Hospital, Asian Polyclinic, Swaraj Sagar Pradhan, Nirajan Rimal, Professor Dr. Rameswar Adhikari. These are all those awesome people who helped us in our journey, and those institutions helped us to actually experiment on those ideas. And without their help, we could not accomplish this problem, or we could not come up with this solution. So everyone, that was us, and that was all our project. Thank you for your time. Namaste.